When you think about artificial intelligence, it just feels so cutting edge, doesn't it? Like server farms, deep learning,
Yeah,
all very 21st century.
it definitely has that feel.
But the core ideas, the intellectual seeds of AI, they actually go back thousands of years. We're talking ancient Greece.
Millennia, yeah. It's quite something.
And you shared some fascinating sources with us, wanting a deep dive into exactly that, the real history, the philosophy that underpins modern AI.
Mm,
So that's our mission today.
mm.
We want to trace that line, show how these abstract thoughts about thinking itself from guys like Heraclitus and Aristotle eventually became the code running on machines today.
And what's really striking is realizing AI wasn't just some sudden invention.
Right.
It's more like the culmination of this long, long process of trying to figure out how to formalize cognition, how to make thinking something, well, computable.
So every algorithm we use today, it's standing on some kind of philosophical bedrock.
Pretty much, yes. Deep philosophical choices were made along the way.
Okay, let's get into that. Thinkers thousands of years ago, I mean, before electricity even, how did they provide a foundation for today's algorithms? Where's the starting point?
Well, you really have to begin with the pre-Socratics.
Yeah.
They were grappling with these big ideas about how the world works, specifically concepts like order and change, trying to build a framework for systems that are dynamic, that adapt.
Which sounds a lot like what we want AI to do now.
Exactly. Take Heraclitus, for instance. His whole idea of flux, that everything is constantly changing, the can't step in the same river twice idea.
Yeah, famous quote.
It's incredibly relevant. That insight basically anticipated the need for any intelligent system to cope with and adapt within an environment that's always shifting, always unpredictable.
Huh. So the need for algorithms to handle constantly changing inputs, that philosophical need was identified way back then.
You could say that, yeah. It directly impacts how we design algorithms today that need to handle dynamic data streams. Think about fraud detection systems.
Oh.
The fraudsters are always changing tactics, right? If your AI model assumes a static world, it's useless almost immediately. Heraclitus kind of nailed the need for adaptive learning, philosophically speaking.
That's a really clear connection. So Heraclitus gives us this idea of adaptation, the need for fluidity. But AI also needs structure, right? Reliable rules. Where did that come from?
Ah, that's the other side of the coin. And that really points towards Aristotle.
Aristotle, okay. Logic?
Formal logic, yes.
Mm-hmm.
Specifically his work on syllogistic reasoning. This was really the first systematic method for deductive reasoning, step-by-step, structured thought.
So if Heraclitus is about change, Aristotle is about reliable structure.
Precisely. He provided the framework for unambiguous logical deduction. This became the direct groundwork for what we later called symbolic AI.
And how did those first AI pioneers actually translate Aristotle's logic into computer programs?
It was surprisingly direct. They took Aristotelian logic, these formal rules of inference, and basically built them into the architecture of early AI systems.
Like expert systems.
Exactly like expert systems and rule-based systems more broadly. The whole idea was, if we can just define all the rules of a domain, like medicine or geology, we can program an intelligent expert.
So things like theorem proving or structured problem solving.
Perfect examples. They showed you could operationalize formal logic on a machine. It was pure deduction based on defined rules.
But, and this seems like a big but, that kind of perfect rule-based structure.
It has limits, right?
Especially when you hit the messy real world.
Oh, absolutely. That rigidity is its Achilles heel.
How so?
Well, if the problem fits the rules perfectly, if A is true, then B must be true. It works beautifully, it's transparent, you can follow the logic.
Okay.
But the real world is full of ambiguity, context, nuance, things Aristotle's logic wasn't really designed for. Think about understanding sarcasm or diagnosing a complex illness with subtle symptoms. Rule-based systems really struggle there.
Because the world isn't always neat logical proposition.
Exactly. The philosophical structure was elegant, but reality is messy.
So we have these ancient philosophical concepts, flux on one hand, rigid structure on the other, setting the stage. But they stayed as just ideas for centuries. What was the spark that let us turn them into actual computation?
Technology had to catch up. For a very long time, the philosophical debates were there, but the tools weren't. The absolute game changer was the arrival of digital computers.
The 1950s.
Right. Suddenly, you had machines that could actually manipulate symbols according to rules. These weren't just calculators, they were potentially thinking machines, or at least symbol processors.
So researchers could finally move from just talking about can a machine think,
Yeah.
to actually trying to build one?
Precisely. They could run experiments. The computer became this universal tool for testing out ideas about logic and reasoning.
And that leads us right to 1956, the Dartmouth Workshop, often called the birthplace of AI as a field.
That's the moment it gets formalized, yes. And it coincides with this cognitive revolution idea, thinking about intelligence as fundamentally information processing.
Okay, and what was the core philosophical bet they were making back then? The guiding theory.
The big one was the physical symbol systems hypothesis, or PSSH, proposed by Alan Newell and Herbert Simon.
Right, PSSH. What did it actually state? Because it seems foundational for that whole era.
It made a really bold claim. It proposed that having a physical system that can manipulate symbols according to rules, that this is both necessary and sufficient for general intelligence.
Sufficient. So basically anything that can shuffle symbols correctly is intelligent.
In principle, yes, that was the hypothesis. They were essentially saying human thinking is symbol manipulation. If we can get a computer to do the right kind of symbol manipulation, we will have created intelligence. Mind as a logic machine.
Wow. So the goal wasn't just clever programs, it was literally modeling the human mind with logic. Did they have early successes that back this up?
They did, which really fueled the field. Programs like Logic Theorist emerged around that time.
What did it do?
It was designed to prove theorems from Whitehead and Russell's Principia Mathematica, and it did. It found proofs for dozens of theorems, sometimes even finding more elegant proofs than the human mathematicians had.
So it worked. It validated the symbolic approach.
It certainly seemed to. It was a powerful demonstration of automated deductive reasoning, Aristotle's logic running on a machine. It really cemented the idea that encoding knowledge as logical rules was the way forward. Symbolic AI was king.
But, as we hinted at before, the limitations started to show. They could prove a theorem, but maybe not recognize a picture of a cat.
That's a good way to put it. The approach was powerful in structured domains, but very brittle when faced with the ambiguity and sort of common sense aspects of the real world.
The system couldn't handle things outside its strict rules.
Exactly. And this brittleness, this lack of real-world robustness, started getting heavily critiqued, most famously perhaps by the philosopher Hubert Dreyfus.
Dreyfus. He really challenged the whole PSSH idea, didn't he? What was his main argument?
Dreyfus argued that human intelligence isn't just about explicit rules and logical deduction. So much of what we do relies on tacit knowledge.
Tacit knowledge, meaning
Meaning the stuff we know but can't easily write down as rules, like intuition, common sense, the skills you get from experience, like riding a bike or recognizing a friend's face instantly. Dreyfus said rule-based systems could never capture this embodied intuitive expertise.
he argued true understanding needed context, maybe even a body, which a symbol-crunching computer didn't have.
Pretty much. He argued that the PSSH was fundamentally mistaken about the nature of intelligence.
Okay, so if the purely rule-based symbolic AI approach, which we could maybe call the rationalist approach, was hitting a wall, what happened next? How did the field adapt?
Well, it led to a major shift. Researchers started moving away from hand-coding explicit rules and towards systems that could learn from data.
So learning becomes key.
Exactly. This meant exploring things like probabilistic modeling and, crucially, artificial neural networks. These approaches prioritize adaptation and pattern recognition from examples, rather than predefined logical steps.
And this isn't just a technical shift, is it? It connects right back to those philosophical roots we talked about.
Absolutely. It's like that ancient philosophical divide playing out in code.
So
Symbolic AI, with its focus on logic and rules derived from reason, clearly embodies the rationalist tradition in philosophy. Think Plato, Descartes, Leibniz, knowledge through reason.
okay.
But these newer approaches, like neural networks learning from vast amounts of data, they draw much more heavily from the empiricist tradition. Think Locke. Hume knowledge comes from experience, from observation.
So rationalism is like having the perfect recipe written down.
Yeah, a detailed logical recipe. If you follow it exactly, you get the result. But if something unexpected happens, like you run out of an ingredient, the recipe doesn't help. It's brittle.
And empiricism.
Empiricism is more like learning to cook by trying things out, tasting, seeing what works over thousands of attempts. You feed the system, the neural network, tons of examples of good and bad meals, data, and it learns its own patterns, its own internal feel for cooking.
More adaptable then. Can handle surprises better.
Much more adaptable to novelty and ambiguity. But the downside, is that it's often hard to understand why it made a certain decision. Its internal rules are learned, complex, and often opaque, not like the clear logic of the old systems.
This is fascinating. So as AI embraced this more adaptable empiricist approach using machine learning and neural nets, it got much more powerful, right?
Exponentially more powerful in many real-world tasks. Yes, vision, language, prediction.
But then the focus of the debate shifts again, doesn't it? It moves from can we build intelligent systems to how should we build and use them? The ethical questions loom large.
Precisely. Once the systems become effective learners from data, the philosophical questions pivot towards the consequences of their decisions. The failures of the empiricist model often manifest as ethical problems.
How does the technical nature of these learning systems tie into ethics and things like bias?
Well, remember, these systems learn from data. If the data reflects existing societal biases, gender bias, racial bias, economic inequality, the AI will learn those biases.
And potentially amplify them.
And potentially amplify them, yes, because it learns the patterns it sees, including the unfair ones. So you get concerns about algorithmic bias in things like loan applications, hiring, even medical diagnosis.
And unlike the old rule-based systems where you could point to the faulty rule.
With these complex neural networks, it's much harder to pinpoint why a biased decision was made. That opacity creates huge challenges for accountability and fairness. We gain adaptability, but lose transparency.
It's a fundamental trade-off.
It is. And add to that concerns about data privacy, job displacement, the potential for misuse. The ethical landscape becomes incredibly complex.
So given this long history, these deep philosophical tensions playing out in code, and these urgent modern challenges, what does this mean for people actually building AI today?
It means AI development has to be interdisciplinary now. It's not just computer science or engineering anymore.
You need the philosophers back in the room.
You need the philosophers, the cognitive scientists, the sociologists, the ethicists. You need to understand the philosophical choices embedded in your technical decisions. Are you optimizing for pure accuracy or for fairness, for adaptability or for transparency?
Because those choices have real-world consequences.
Massive consequences. The goal has to be building systems that are not just powerful, but also aligned with human values, ethically conscientious. That requires this broader perspective grounded in AI's deep history.
It really has been an incredible journey to trace, from Heraclitus worrying about flux and Aristotle defining logic.
Through the rise and limitations of purely symbolic AI, the rationalist stream,
To today's powerful but sometimes opaque learning systems, embodying more of an empiricist approach, and the struggle to manage them responsibly.
and understanding that history really matters for you, the listener. Because it shows that every algorithm making decisions out there today, whether it's recommending a movie or screening a job application, it's built on these foundational philosophical choices.
A choice between structure and adaptation, reason and experience.
Exactly. Recognizing that helps you ask better questions about the technology shaping our world.
So, maybe a final thought for everyone to chew on. The sources talk about proficiency evolving through experience, not just static rules. Think about unsupervised learning, where AI learns patterns in data without any human labels or guidance. Could you see that kind of self-discovery, that unguided learning from the raw flux of data, as maybe the ultimate computational expression of Heraclitus's ancient idea? Perpetual change, finding its own order. Something to think about.